Hello, everyone. Thank you for joining us.
And hello from me as well.
Hello.
So we're really excited.
Go on, Pete.
Right. So we're really excited today. We've got Minko from the Angular team who's going to give us a talk today. This is our third online Angular meetup this summer. We're starting to get some ahead of steam now. So looking forward to a few more over the next few weeks. If anyone who's watching is interested in giving a talk, then we'd really love to hear from you. Love to hear from some people who've got stories from around the UK or London or Europe even. It'd be really cool to hear from you. So the way that we're going to work this is the same as the previous ones. Minko is going to give a little bit of a talk for about half an hour or so. If you would like to ask questions, you can post them in one of the two streams. Today we're going to be streaming both on Facebook and YouTube, and you can add comments in either of those two places, and we'll bring them up at the end so we can have a little Q&A session at the end. And then after that, we will break out into a Zoom meeting where we can do a bit of networking and more sort of face-to-face chat. And I believe Josh will be posting that towards the end, so you can jump on that at the end. Anyway, without further ado, I'd like to introduce Minko. He's going to tell us a bit about himself already, so I've been told not to talk too much about him. But welcome to Angular London Meetup, Minko, and thanks for coming. I'll hand over to you.
Awesome. Thank you very much for having me. Yeah, so my name is Minko Gechev. I'm an engineer at the Angular team at Google. Today, in this presentation, I would want to share with you what is the current state of Angular. Pretty much the way that I have focused the talk is we're going to go into more theoretical details, which probably can give you some better context on some of the technical decisions that the team has been making over the past couple of years. And right after that, we're going to dig into a couple of initiatives that we kicked off over the past few weeks, including the roadmap. We're going to look at current projects and what we'll be working on in the future. And that's how we're going to finish the presentation. We're also going to briefly mention a project for which we're running on RFC that, in fact, Pete is currently leading, which is related to distribution of Ivy libraries and the Angular linker. I'm sure that most of you are already familiar with Angular, but let me still give you a very brief introduction on what we're offering as a platform. So we have the framework, clearly. This is Angular/core. With the framework, we're providing you with different primitives to build scalable web applications. So something that puts us in a unique position is that we are encouraging folks to follow best practices from the very beginning. So you're going to see some things such as strong typing, like static typing with Typescript. You're going to find dependency injection and very strong separation of concerns. However, in order to start building Angular applications, you don't need anything else than just knowing how to develop Angular components. From there, gradually, you can get introduced to the different concepts that the framework provides. So on top of that, we have the Angular tooling team that is responsible for building our command line interface. And we have the Angular components team. They're building the CDK, the component development kit, that provides you with different primitives that you can use on a higher level. For example, components such as a drag and drop or different material design components. And on top of that, we have a variety of other tooling. We have I18N. We have language service that provides you with great support for text editors and IDEs for Angular templates, router, and so much more. It has been actually quite a long journey to reach the state that we're at right now. Currently, we're pretty stable and focused on a lot of different incremental improvements in order to simplify the framework, improve its stability even further, and make it generally faster with better characteristics providing better development experience. Currently, we have, I would say for sure, tens of thousands of projects outside of Google. It's actually really hard to measure because really large portion of the Angular projects outside of Google, they're still internal systems in other companies, which are behind firewalls. From the public websites, we have quite a few. There are a lot of really large customers using Angular, such as the NBA. We are also working very closely with different large partners, such as VMware. and so much more. Only inside of Google, we have over 2,600 projects right now. These are not experimental projects. These are all projects that are clearly actively being developed to serve different purposes. Some of them are very small. For example, just showing you some information about the cafeteria inside of Google. And others are really large. We have the Google Cloud Console developed with Angular, which has several millions of lines of source code. Now let us dig a little deeper into the theoretical foundation for some of the decisions that we have been making. So I have been giving this overview quite a lot over the past few months. And this is primarily because I think that the tooling that we have and the compiler that we have on top of the framework is putting us in a really unique position. We can add some extra constraints, which generally can make the framework faster in a lot of cases. And not only faster, but also smaller, with potentially even better developer ergonomics, helping you to catch many more issues ahead of time. There is this trade-off for predictability versus flexibility. This is mostly from a real-world trade-off, actually. Imagine you have a really predictable schedule. Your calendar is booked from the very moment that when you wake up to very late in the evening when you're going to bed. And everything is really well scheduled up to a minute. You know when exactly you're going to meet with someone. You know exactly when you're going to have a meal. You're probably going to be quite productive, especially if you're in such a state of mind that you're already used to the schedule and you're just transferring fluently between the different tasks. However, it's very hard to introduce something dynamically in your schedule, something that is going to, for example, drop ice cream during lunch or something, like having a break with friends. Having very flexible schedule, however, where your schedule is pretty much open and you can improvise, do different activities. This is the other end of the spectrum. You can do whatever you want, and you might not be as productive as with the predictable schedule. So both could be excellent, alternatives, with different trade-offs. In the world of compilers and programming language design, we're often talking about a similar trade-off, which we're referring to as static versus dynamic. We can put different programming languages on this axis to give you a better idea what I mean by that. Idris, for example, is a very static language. It has extremely powerful type system, which could be also quite restrictive in a lot of the times. Haskell has super powerful type system, for example. The Haskell compiler can understand your program really well just by looking at its source code without having to execute it, just statically analyzing the source code. The Haskell type system is going to help you to have almost zero runtime exceptions because it handles everything statically and provides a static verification for you. Rust allows you to manage your memory just by using its powerful type system, so it's really powerful as well. However, it has this build step, and often you find yourself fighting with the compiler to get your program actually functioning properly. On the other side of the spectrum, we have JavaScript and Ruby. These are all super dynamic languages. They don't have a build step. You can just take a script, push it into the browser, and the browser is going to start executing it. And it can potentially compile some pieces of it with the just-in-time compilation, but generally this is not a requirement for you. You can just take the source code, push it into the browser, and it is going to function just well. However, it is great for rapid prototyping, but when your project starts scaling more, it's harder to grow without having some static guarantees that the compiler provides for you. TypeScript is somewhere in the great middle, I would say. It has quite powerful type system, which helps you catch issues ahead of time and provides you with development experience, having great text editor and ID support. But at the same time, it is not too restrictive. So you can still quickly build applications, especially because you have flexibility around the constraints that the TypeScript type system is going to set on top of your program by configuring the compiler with different flags. It is interesting that it's very easy to make a program from static to dynamic. You just need to relax some of the constraints that you have set originally. For example, in a TypeScript program, you should just drop the type annotations, and you can have a very dynamic JavaScript program. But if you have a very dynamic JavaScript program, it could be quite challenging to make it static, to align to the most strict type annotations possible in TypeScript. Now, talking about these like theoretical ideas, I see that like both of these sides of the spectrum, they have their own pros and cons. For example, the static systems, they can perform really great compile time optimizations. Imagine you don't really need to run your program for the compiler to understand it. So the compiler can take your program and transform it to a more efficient version of itself. The type system of the compiler is often guarding us from like getting into common scenarios which we can like shoot ourselves in the foot. They can help us to prevent some common errors ahead of time. And also in Angular specifically, thanks to the fact that we can statically analyze our Angular templates, we can have zero overhead internal serialization. With the Angular internal serialization, you actually like Pete gave a like very in-depth talk on the previous Angular London meetup about that. But for example, with the Angular internal serialization, you don't need to specify any data binding instructions for the individual translations, for the individual strings in your templates, because they're all inlined, and we're performing this inlining as part of the build step. From there on, well, nobody needs to think about internal serialization because you have different versions of your application for different languages that you support. On the other side of the spectrum, we have pretty great benefits as well. If our system is very dynamic and we don't have anything happening at build time, this means that our build is going to be much faster, or potentially we're going to have like zero build time. Anyway, we can also very dynamically assemble our user interface, since it's not something that should be statically known at build time. We can dynamically assemble it once our program starts running. It's actually running. This is a thought which is for sure not something that as like I came up with and like a very smart statement. This is something that many people have had in their heads like many years before I was even born. That's why there is such a very active research in the compiler design and type systems. Generally, it is much better for you to get an error ahead of time before you ship your application to production. Getting a build time error potentially means that you have something like incorrect, something wrong in your program that you can fix before you actually provide your system to the final users. So really having the opportunity to have this build step, which is something that you pay for only once, and benefiting from this just by having some issues getting visible to you before you ship your application to production is a really powerful feature. There is a paper which sets a number on how powerful TypeScript could be in your day-to-day development process, actually. Different researchers, they sat together and they empirically prove that you can actually fix about 15% of the bugs in your program just by using TypeScript. They looked at different open source projects developed with JavaScript, and they analyzed each one of the issues in the issue tracker, and they tried to predict how many of these issues would have been detectable at build time just by adding some TypeScript or Flow type annotations to these JavaScript programs. They figured out that 15% of these issues would have been detectable by the TypeScript type system. Imagine if you have had the opportunity to catch these errors ahead of time. This means that your users would have never had to experience them. They will have never had to report these issues, and you'll have never had to spend a lot of time in fixing these issues and releasing the software that you developed. And this research was done with TypeScript 2.0. I believe TypeScript 4.0 is coming out today. So now we have so much more powerful type annotations and like type system that TypeScript provides. So I believe this number is much more above 15% right now. Now let's spend just like 2 minutes talking about Angularjs and Angular. Pete has actually had much more experience in this space compared to what I have, since he was actually the one who merged my first pull request to the Angularjs repository like maybe 7 years ago or so. But Angularjs is very much on the dynamic part of the spectrum. There, we don't have tooling that is performing like any build time checks. We just have a bunch of scripts that we add to the browser, and we can build pretty much anything we want there. So we don't have the guarantees and the static optimizations that we're getting from the static systems, but we can very rapidly prototype things. However, over time, the requirements of the business, they started increasing. People started building so much more complicated applications with JavaScript. And this way, we had to come up with a more like scalable and strict solution. So that is why the team, also knowing that it's easy to go from static to dynamic, but it's really hard to go from dynamic to static, Angular 2 was born, and it was a really static system. The compiler was setting a lot of constraints, especially on provider, especially around dependency injection, where you weren't able to declare very dynamic expressions since the compiler was supposed to understand them at compile time. So you weren't able to use, let's say, arrow functions or so. Later on, however, Angular became a little bit more dynamic, and that was fine. We didn't have to break projects because we just relaxed some of these constraints that we were setting. And with Ivy, with version 9, things got even more dynamic. But at the same time, we didn't give up a lot of the features that we were getting from a static system. For example, Ivy still produces very efficient JavaScript instructions for your static templates that are really fast to render and super fast to perform change detection on. We still have this zero overhead internationalization, and we even improved it. So you don't have to build your application multiple times for different languages. You can build it only once, and right after that, perform different string replacements. And we even have stricter type checking right now with strict templates. Right, that was about 15 minutes of theory. And now let us talk about what is new in Angular, because I believe one of the biggest changes and like improvements that we did was that, in fact, we currently have a roadmap. So version 10 and beyond. I guess the biggest feature that we announced as part of version 10, because that generally was a very small release, was the opt-in strict mode. By using Angular CLI version 10 and above, you can actually specify a -- strict flag that is going to generate a project which has stricter configuration that is going to allow you to allow you to catch many more issues ahead of time, enabling stricter Typescript type checking features. And also it is going to let us tree shake your application more efficiently, since we'll be using different like tree shaking functionalities from Webpack. Some of the features that we enabled are, like as I mentioned, stricter Typescript type checking, and also strict templates in Angular. We're going to even stricter. In strict mode, we even have enabled the know any rule in eslint. And yes, we'll be migrating to eslint. This know any rule has its eslint equivalent. We're also restricting the bundle budgets. So the bundle budgets is a functionality in the Angular CLI, which warns you when your JavaScript bundles become bigger than certain size. For example, if your bundles are larger than 5 megabytes right now, which is I would say, like pretty low requirement, your build is going to fail. However, with version 10 with strict mode, if your bundle gets larger than 1 megabyte, we're going to fail your build. And we're going to even throw you a warning if your bundle gets bigger than 500 kilobytes. Another improvement or like feature that we're introducing in strict mode is assuming that your source code has reduced side effects so that we can tree shake it more efficiently. This is a longer topic. We'll be publishing a blog post on Angular.io, which gives you more details, which is going to provide you more context on what exactly does this mean and whether it is good for you or not. But let's for now just assume that this may even break your source code, your final application, if you have some side effects performed as a top level, like expressions in your modules, and we decide to tree shake them. Well, generally, these are all pretty restrictive, like pretty tight constraints. So by building your application, you'll be getting more of these compile time errors. But just remember, this is actually a good thing. If you're getting these compile time errors, this means that you have had issues in you're actually having issues in your applications, and you can catch them ahead of time before shipping your apps to production. So this fight with the compiler is actually worth it in the end. We have also worked on making Commonjs as an opt-in. Currently, if you're consuming Commonjs modules, we'll be throwing different warnings in the console. This is primarily because Commonjs generally is making your bundles larger. Since Commonjs is a very dynamic module format, this is again related to static versus dynamic. Having very dynamic module format does not allow the bundler to optimize it efficiently, because require, which is the way for you to require modules, with Commonjs accepts an expression, and this expression can just like specify a module name by using some runtime information that is even not available at build time, and the compiler has no idea how to statically determine which modules, which exports from this module you're using or not. This is a much longer topic. If you want to get more details, you can take a look at this blog post at web.dev that I worked on a few months ago. All right, so the final thing that I would want to talk about is how we're working on increasing the visibility of Angular in general and being just more inclusive open source project. 3 weeks ago, we published our roadmap. And in this roadmap, we're also describing how we're prioritizing, how we have been prioritizing features recently. So in the roadmap, you can find different efforts, both external and also some internal efforts, on which we have been working on and which we will be moving in the future. Generally, by looking at these projects, you're going to see that our focus is on stability, development experience, and speed. We really want to also simplify the getting started journey with Angular. So some of the efforts are, for example, dropping concepts from Angular, which are not essential for the getting started journey, just making these concepts optional so that you can start using them whenever your applications require you to do so, when your application starts growing more. Let's look at some of these projects. So the current projects that we are actively working on is increasing the visibility of test harnesses. Test harnesses are just different abstractions which are primarily used for unit and end-to-end testing that allow you to interact with these different components that we provide in Angular material and the CDK without coupling to the internal structure of the components. So this way, the internal structure, which is currently a private API, their DOM structure, you don't have to, we're not going to pretty much, if you're using harnesses, instead of checking directly what classes different DOM elements, for example, have, we're not going to break you when we change it, when we make it more optimal. This is a pattern inspired from the page object pattern that we have been encouraging you to use for a couple of years already with Protractor. We are already actively working on support for Typescript 4.0. This is going to bring some interesting improvements. For example, I believe the biggest feature in Typescript 4.0 is variadic types. We will be reevaluating our end-to-end testing strategy, considering also some state-of-the-art testing solutions. It's very early to share details on what exactly this end-to-end testing strategy is going to look like, but we realize that this is a really high priority for us. We're also working on migration of the Angular material components to MDC Web. So generally, Google created material design, and Google has this material design team that is responsible for building material design components. Different frameworks in Google, they had different implementation of these material design components. And with the spec evolving, it was kind of hard to keep up to date across like all these different frameworks and their implementations. So what we're doing right now is to make sure that we're better aligned with the spec and we provide high quality accessible components. We will be stepping on top of the material design web components developed by the material design team. and we'll create wrappers for Angular. Our promises here are that we're not going to break compatibility, and we're not going to have any size regressions. Trusted types is another example. Trusted types, they're aiming to reduce the attack surface for cross-site scripting. We have been having trusted types, custom implementation of trusted types in Angular for a while now. We here want to align with the latest features that the web platform provides, so that Angular can be thinner and thinner layer, just using the latest features and being prepared for the future of the web. So talking about the future, we're also going to be aligning with the future RxJS releases. RxJS 7 and 8 are coming, so we're currently evaluating what are the changes there and what migrations we need to do there in order to keep everyone up to date. Ivy libraries is another effort that I'm going to talk about in a little bit. And also we have our project, Bylock. So Bylock, we have about 2,700 issues right now on Angular. This sounds like a lot. Well, when you look at the number of issues and you divide them by the number of modules of packages that we have in the Angular repository, there are probably not that many, but still we can do much better job in triaging them. So currently we have an effort on spending up to 50% of our engineering time in issue triage. The first early results that we got out of this is 30% fewer issues in the Angular CLI, and currently less than 40 untriaged components issues. My guess is that we're currently about like 0 untriaged component issues. I haven't looked at the components repository for a week or two now. Yeah, we have so much more work to do there, especially around moving forward with fixing and like closing some of the issues on Angular core. But well, we're getting there and we're like seriously looking into this. So Ivy library distribution. This is a project that I believe Pete leads right now. Currently with Angular Ivy, we have been encouraging you to keep shipping Vue Engine libraries. Vue Engine is the previous version of the Angular compiler and rendering pipeline. So we have been encouraging you to compile your Angular libraries to Vue Engine and distribute them this way to NPM. However, this was not very efficient because we had to build this Angular compatibility compiler that takes these Vue Engine libraries and translates them to Ivy. So in your post-install steps, you have been seeing some delays. After you install your Node modules, there is the Angular compatibility compiler, which compiles all the different Angular modules one by one to Ivy. And this delay has been inconvenient. Also, we want to come up with an official way to allow you to distribute Angular Ivy libraries. So in the Angular compiler, we're going to introduce a flag called publish library that is going to allow you in this mode to build a library in some kind of an intermediate format, which includes all the different metadata for your directives and components, but at the same time does not expose any private, does not contain any private Ivy APIs that we need to commit to support. For example, the individual Ivy instructions. So you can publish this package. You will be able to publish this package on NPM. But still, you don't worry about that too much because you don't really need to do this yourself. We will integrate it as part of our tooling with ng Packager. I just wanted to give you some insights on the internals of how everything works. Later on, when someone installs your Angular Ivy library, the Angular CLI is going to kick off the Angular linker that is going to translate it to an Ivy library that you can consume in your application. There are so many more details about this project that you can explore in this RFC by Pete and Alex. I believe we're closing the RFC today, but you may still have about an hour or so to just to look at it and share your opinion. We'll be following up with a summary of all the different things that we learned from the community feedback, and we're going to follow up also with the implementation after that. And finally, I want to share some of our future projects. So very high on our priority list is migration to eslint. Although eslint has its own trade-offs. For example, it consumes so much more memory because, well, it doesn't reuse the Typescript abstract syntax tree for linting. It builds its own custom one. And it is also quite slower, exactly because of this transformation. It is becoming the industry standard. So we should just figure out how we can mitigate these risks and how we're going to perform migration to the latest tooling. We'll be also working for better forms, because forms has been probably #1 package for which the community has been requesting more improvements. We're working on Webpack 5. This is also a really highly demanded feature from community, which is going to speed up the build of the Angular CLI generally, because this has persistent disk caching. And this is one of the key features that Webpack 5 provides. Another important and large project that we haven't started working on yet, but is quite high in our priority list, is optional zones. We want to make Zone.js optional, and not only, well, currently Zone.js is optional. In fact, you can specify that the ng zone is no operation. But in this effort, we would want to provide better primitive for triggering change detection manually, and also even local component state management. We'll be removing the view engine. So this is going to have some public API changes and impact for everyone as well. Not in a bad way, because we'll be thinking about migrations. But it is going to simplify different APIs. We will no longer be dependent on different ng factories, which is going to allow us to make the APIs generally simpler and smaller. DevTools is another project I'm excited about. I'm actually going to talk about DevTools just in a minute and give you more details about it. Optional modules, ng modules, is one of these efforts that are aiming to simplify the framework. We haven't designed this solution completely yet, but we have some ideas how we're going to, for example, allow you to declare what is the scope of a particular template. And this way you wouldn't have to deal with ng modules from the very beginning when building an Angular application. Eventually, if you think that ng modules make sense for you for structuring your app better when your application starts to scale, you would be able still to use ng modules. But if you're building a very small application for which modules are just going to be an overhead for you, you wouldn't have to do that. And finally, optional ng modules are going to allow us to also enable more ergonomic component-level code splitting. This is currently possible, but you would have to use some kind of legacy view engine APIs, even with Ivy that we have polyfilled, and you'd have to deal with ng modules to declare the context of a particular component. Now, let me just share a few words about Angular DevTools. Generally, with this tool, we're aiming to provide similar capabilities that Augury used to provide. We're actually partnering with the Augury team on this. So you'll be able to explore your component structure. You'll be able to change different properties, trigger Angular change detection, and see what happens. But on top of that, you'll also be having a profiler tab, which will be providing insights on how often your change detection runs, what triggered it, and how much time you're spending in your individual components and directives in terms of lifecycle hooks and change detection for your components. I guess that was pretty much everything. I genuinely hope that you were able to see how our focus has been primarily on stability, development experience, and speed. We really hope to make the framework also just continue this direction which we have been heading to, just enabling best practices from the beginning, but in a very accessible way, so that not only advanced users would be able to take advantage of all of these features, but also folks who are just getting started with software development. That was everything from me. I would love to continue with the Q&A. Also, if you have any feedback about this talk, please feel free to fill the form at mgv.io/talk. Thank you.
Thank you very
Fantastic,
much.
Minko. Thank you very much for that. It was really interesting to see some of the direction that the Angular team are going to be going in and the motivation behind it. We've had a few questions already during the talk, but if anyone who's watching now thinks of a question, then now's your chance to get it into the chat so that we can ask Minko during the next few minutes.
So Pete's been asking quite a few questions, but I think we'll start with someone else. What is your opinion about third-party packages like Cypress, Jest, NGX Translate, and X Workspace, which, as I see, seems to be more dev-friendly and feature-rich than the built-in ones?
Yeah, I'm actually using Cypress in some of my projects as well. I really like the ergonomics, developer ergonomics it provides. I think these packages are all great. They're like, we cannot really provide the same guarantees that we provide for built-in packages that, well, if the public API change, we will be moving you forward with them. But if you clearly understand their trade-offs, you can feel free to use them. For example, NGX Translate is quite powerful. It provides this runtime, allows you to dynamically change the language of the page, like without refreshing the page. If this is a super critical feature for you, then you can go ahead and use it. At the same time, you wouldn't be getting some of the benefits that our Angular built-in internal serialization provides, where we're providing you this solution with zero runtime overhead, for instance. So yeah, I would recommend you to just look at them, really understand their trade-offs, and go ahead with the best solution for you.
Great, thank you. So let's pull in one of Pete's questions. So how do people get the Angular team to consider a future project, and how do you prioritize them?
Yeah, we have a lot of different channels from which we're receiving feature requests. We're getting feature requests from some internal projects, from a lot of external customers, which we're receiving either on GitHub, social media, just like interviewing these customers, talking with people on meetups and conferences. So we generally have a huge bag of different features, depending on how frequently we're seeing these features occur in community and among our partners. We're assigning them different priorities, and we are just adding them in our prioritization process. This is just one of the inputs, actually, because at the same time, the Angular project has some technical debt that we need to take care of. And of course, we also have some infrastructure work, which is going to make us just more efficient shipping new features and versions of Angular. So once we have all these different features, we have different prioritization meetings in which we're positioning each one of the features in the backlog to one another, just relatively, so that we can sort them in something like a kind of a sorted list, or like a priority queue, where we're taking them one by one, and on completion, we're shipping them to everyone.
I think it's also worth saying, Minko, that that these kind of projects are like chunky ones. We're not talking about like small bug fixes or little like improvements to the quality of components, whatever. These are sort of tasks that will require more than one developer over from a week to a few weeks or whatever. And also, I think it's worth saying that each of these projects has to have a proposal that's written with a certain template with information about the impact it would have and the effort and so on. And this is all taken into account when it's being prioritized, isn't it? I think that's fair to say.
Yeah.
So staying on that, these future projects, will there be scope for developers from outside the Angular team to be involved?
Some of them are easier to. So one of the really big benefits that I see for the Angular project, and this could be also valid for other projects out there, like React might be offering like similar benefits as well, is that we have this huge CI where we're able to very easily test compatibility of changes. For example, when someone pushes changes to even a private API, which has unpredictable effect on the public API surface, this may break large number of our customers. Like, by customers, I don't mean specifically Google projects. I mean like Angular projects in general. And so the tricky part there is that we cannot, unfortunately, provide access to everyone to this huge CI, because these are some like business critical projects for Google. So we cannot share the source code of, let's say, Google Cloud Console, right? so for some of these projects which are very heavily used across the globe, we can track this backward compatibility relatively easy as Google employs. But for community, it's really hard to understand. Every time when I say Google, my Google Home, my Google Assistant actually wants to talk to me. But for for folks who don't have access to the CI, it's really hard to understand what is the exact impact of each change.
Yeah.
So this makes it hard to implement large features. It's usually it's usually possible to implement bug fixes and relatively easy possible. But for large features which have very large impact on top of the entire platform, it's quite tricky.
Yeah.
It's also worth saying that we do have a collaborators program where people who've been quite active on GitHub and engaging with the team are encouraged to be given more access and work on sort of more significant parts of the code base. And there's been a handful of people over the last few months who've started doing that. So Stephen, if you're interested in being involved in particular projects, then there's nothing stopping you from reaching out and volunteering. And I for one would always be very happy to work with someone if they want to get involved.
But that's where to start, though, isn't it? On GitHub and getting involved in the discussions and the bugs.
It's a really good place to show people that you have the skills to help and the interest the engagement.
Cool. Okay. Any update to Angular elements in the pipeline?
Yeah, I've been asking different folks what exactly new features in Angular elements they have been looking for. I'm going to assume that you're referring to just making Angular elements smaller, because that's what's the main feature that I have been hearing about us. Yeah, so that's a quite tricky question there, because generally that's hard to achieve. When we build Angular elements, we can just produce different Angular components which are referencing different instructions, IV instructions. In order to make the bundle smaller, this means that we shouldn't introduce these IV instructions and Angular runtime as part of the distribution. If we don't include it and we don't know ahead of time, yeah, smaller and fixing zone issues. So I'm on the right track. So if we don't include this part of the runtime ahead of time, this means that we don't know what exactly pieces of the framework you will be using when you introduce this Angular elements to a web page. And unfortunately, we also don't know which elements you'll be using on this web page. So we need to provide you with the entire Angular UMD bundle to take advantage of them. The zone part. The zone part, the project which is related to optional to the optional Angular zones, this is going to solve the issues that you currently have in mind related to Angular elements. Okay. About CSS bundling, we are producing CSS, the scope CSS for each individual component separately. I'm not sure what exactly the problem is here.
So if you want to join our networking afterwards, maybe you can carry on the discussion. There's a question here about the new dev tool. Is that available? When will it be available?
Yeah, it should be. We're currently in a very early alpha testing. It should be available if we find that it provides value to people. It's going to be available probably in the next couple of months, I would say. So maybe around the end of the year. Still don't want to commit to a particular timeline, because when we test it with people, it may turn out to be to have zero value proposition, and in this case, it may even not make sense to ship it. But
sure. So I've got a question. I thought the strict mode was really interesting, but what happens if I wanted to customize it slightly, maybe not go as strict? Is there a way of doing that?
Yeah, these are all Angular CLI configuration settings that you can pick from. We'll be publishing a blog post which explains the impact of each one of these configuration settings in the next week or so.
Cool. That's something to look out for. Okay. I think we've got another one from Pete. Let's see. We've got quite a few from Pete. So, what about the harnesses?
I'm full of questions. If only I had the answers.
Is there support for building our own harnesses, or are these harnesses extendable for our own components?
That's an excellent question, Pete. I don't know if you know the answer of this one.
I know it wasn't rhetorical. No.
Okay.
I've not used these harnesses at all because I haven't been working on building apps using the material design components. So I'm just interested in how we can use them more.
I have about, let's say 95% of, like, I can give you an answer with about 95% of like confidence. The material team, the components team has been building different harnesses for components. I don't believe they're extensible. I just believe that we're providing them for the current set of components that we provide as part of Angular components and material. But you should be able to implement custom harnesses, like following the same pattern. We might be providing some primitives that you can extend.
Cool.
So I think we've kind of run out of time for the moment. So thank you very much, Minko, for joining us. I'm just about to post on the chat the Zoom link, which will be starting soon. So please join us there, and we'll carry on the networking there. And thank you very much for joining us. And we hope to see you next time.
Yeah, we really appreciate your time. Thanks, Minko. And look forward to hearing from people who'd like to give a talk in the future.
Definitely.